Even if nobody's here live, I'll still just record a presentation so that people have something to watch, even asynchronously. And if someone's here, then you'll get the chat going to yourself. I totally get not always showing up, especially on a weekday. Weekdays are, especially 9 p.m. are pretty rough. Yeah, I know I'm pretty tired, but it's just how it goes. Probably get started in just a minute. I think I'll just start the presentation, and hopefully everyone gets to watch this. So we're going to be talking about object-oriented programming today. Now, object-oriented programming is one of the more common kinds of programming. You might also hear it in the same sentence as functional programming or other programming paradigms. Most modern languages are written with object-oriented programming in mind, although functional programming is also pretty popular, especially with languages like JavaScript. And then There are other things like, there are Java derivatives like Scala or Kotlin, which are actually, they're still object-oriented, but are actually much more functional. But we're just going to be talking about the objects today. Understanding this is actually pretty important to understanding a lot of modern code. And if you can get a grasp for objects and classes, then it's a lot easier to really understand other people's code as well, especially if you're looking at something on GitHub. So basically, object-oriented programming, it's called a programming paradigm. So it's a way that people construct their software, and it's a way of bundling properties and behaviors, or attributes and behaviors. So it's basically just taking, I like to think of it as just like creating, your own data structure. So, for example, we could create, so like in this image right here, this is essentially showing the object-oriented concept of inheritance. So the first one, we have an instrument. So every instrument, it has a, it has a type, whether it's brass or a stringed instrument or a percussive instrument. And then a guitar is a type of instrument. But a guitar has other features that not every instrument has. And then acoustic guitars, electric guitars, and bass guitars are all types of guitars, but they're also different in their own ways. So you'll see it a lot, this concept of inheritance, and it's not really something we're going to be talking about a lot. It's just something that I am going to show you. But object-oriented programming itself consists of usually these 4 key ideas is what people are looking for. So like, it's a really common interview question in the software industry. Describe the 4 basic principles of object-oriented they won't say 4, just like describe the basic principles of object-oriented programming. And the things they're looking for are inheritance, polymorphism, encapsulation, and abstraction. I'm not really going to go into all of those because all of those are actually pretty dense in and of themselves. Things like polymorphism are actually like sometimes kind of difficult for people to get their heads around. Inheritance is a pretty easy one. It's just basically the idea of one object is related to another more general version of that object. So in the instance of here, in this graphic, we have an instrument. A guitar is an instrument, a piano is an instrument, but then an acoustic guitar is a guitar, an electric guitar is a guitar, and a bass guitar is a guitar, which also means that an acoustic guitar is also an instrument. So inheritance is a pretty easy one to understand. Encapsulation is basically just like putting all the data in one place. Abstraction is taking something more concrete and making it more abstract. I'm not going to go into too many more details than that. Hey Josh, how's it going? So an object is really just a representation of data. And like I said, I like to think of it as developer-defined data. So generally an object will have attributes and it'll have behaviors. So this is kind of showing you another sort of relationship that you can have between different objects. So for example, we have a person here. And we're going to say a person, pretend like this is a database for a school. A person has a name and they have an email. A student is a person. A teacher is also a person. So a student basically has all of the characteristics and behaviors that a person has. So a student would have a name and email, but a student would also have maybe a list of classes that they're taking and the grades that they receive in those classes. A teacher maybe has the subject they teach. And then there are, well, according to this graphic, there are public teachers and there are private teachers. And I don't know, I kind of just Google image searched object-oriented programming and posted this. It's just kind of silly. But like, essentially, like a private school teacher is a person. So a private school teacher is a person, just like a student is a person. But a student is not a teacher. Although you can actually, in some languages, have multiple inheritance, meaning that, essentially like, somebody could be both a student and a teacher, depending on the language. You'll see that. Other languages you don't. I tend not to use multiple inheritance because it just, even if I can, it kind of just causes issues down the line. But yeah, that's basically all I'm going to talk about with inheritance and object-oriented principles, because I really just want to show you how to create objects in Python, and then just kind of like the code that we use to actually construct them. So, as I've said, an object consists of attributes and behaviors. They might consist of some other things, but generally, at the most fundamental level, an object consists of those two things. So, for attributes, you might hear me use the word field or instance variable. For Python, I'll try to just say field, and then for behavior, I meant to say functions and methods, not functions and functions. So a behavior is essentially just like something that that particular object can do. So, for example, a student, in this particular relationship diagram, a student might be able to change their classes. So, for example, a student might drop they might drop journalism as an elective and add photography as an elective. In that case, you'd want a behavior that allows you to actually change that class. So a student might be able to change the class, but a person, you don't want to have that behavior because a person doesn't have anything in their structure representing classes by itself. So you would actually want that behavior to be encapsulated in the student class. So you use something called classes to create objects, and a class is essentially just a blueprint for an object. It's a model, so it's basically saying, like, this is what the object will look like once you create it. An object is actually something, you can actually think of it as a tangible thing, because essentially it is just like, it's an entity taking up space in memory. So when you do that, when you think about it like that, it actually is a tangible thing. It's just kind of microscopic because it's just, essentially just memory, written to memory addresses. But a class is just the cookie cutter, and the object is the actual cookie. So just for the application, I'm going to be showing you how to define a car class and the way we might think about defining a car class. So the first thing you want to do when you're creating classes, you want to think about what are the characteristics of the thing you're trying to represent, the thing you're abstracting. So essentially, by defining a car class, we're defining a model that abstracts the concrete thing car. So obviously, I'm not going to just take an actual car and compress it down and just stick it in virtual memory on my computer. I'm going to build a model, or I'm going to think of a model that's abstract that allows us to represent a car, on a computing system. And then what are the behaviors of a car? So when you're thinking of the characteristics, you want to think, like, what are the things that all cars have that differentiate, that allows them to be unique or differentiate themselves. So the color of a car, the model of a car, how big it is, the size of the fuel tank, the maximum speed, just like, I don't know, there are all sorts of things you can think of that would differentiate one car from another, but you could still look at two things. You could look at maybe like a Hot Wheels car and say, like, okay, well, that's a car in a way. And then you could also look at, just a very mammoth, like a really big car of some sort, and still say that they're both cars. So you want to think about, like, what characteristics do those two things share, so that you can actually represent them or model them in an abstract way. And then what are the behaviors of those cars? So what are the things that all those cars can do? They can go, they can, maybe like they can refuel, they can get an oil change, they can, all these things that all cars can do, although maybe not the Hot Wheels cars, so maybe I was being a bit too abstract with that. But, when you think of your representation, you just want to think, like, what are you trying to represent? And of the things that you're trying to represent, what could you put in the model so that you could differentiate each of those individual instances of those cars from each other. So I'm going to pick 4 arbitrary characteristics of a car. So these are 4 things that could differentiate cars from each other. We're going to say the color of the car, the number of doors of the car, and then the number of seats in the car, and then also the maximum speed of the car. So those are 4 things that you can use to differentiate different cars from each other. Every car has those things, those characteristics, and you can look at these 4 characteristics to differentiate each car from each other and create unique instances of car objects in memory that you can use later. So this is a very basic Python class. This is about as basic as you could possibly make a class. You use the keyword class, and then the name of the class is here. So the name of the class that we're creating is car. And the one thing that I always want to define in a class, although you don't technically need it because a default initializer is created, but I like to create my own initializer. So if we tried to create a car object without a initializer and then just didn't pass any parameters, Python, the interpreter, will basically just try to think about, well, actually, it's not going to know anything. I think it just assigns the value of none to everything because we actually don't know what each of these data types, we don't know what the data types of any of these things are until we tell it what they are. So color, door, seats, and max speed are not necessarily, it's not inherent to the Python interpreter that, a color could be a string and the number of doors and seats could be an integer and max speed could be a floating point number or something. So it's only going to know once we tell it. So I define this initializer, and the initializer is what we use. It's basically it's the cookie cutter itself. It's saying, this is what we have to tell, this is what we have to tell the Python interpreter so that it can create a car object that represents the abstraction that we're trying to create. So in this initializer, you pass the keyword self. So self essentially just means that the method refers to the object itself. It's self-referential. And I'll show you what that means in a second. And then we're passing actual arguments for each of those attributes. So we have the color, the number of doors, the number of seats, and the max speed. So when we say self.color gets color, essentially what we're saying is we want to define a color field or attribute for a car object, and we're going to assign the value color up here. These aren't color differentiated, so it's going to be hard to understand, but maybe this will kind of make it clear. If we say self.number of doors, we're essentially saying that a car object has a attribute or a field called number of doors, and the value that we're assigning to that field is doors. It's the argument that we pass into the initializer here. Self.number of seats, we have a field in car number of seats, and the value that we provide to it, or set to number of seats, is seats, this argument that we pass up here. And then we have finally we have another field here called max speed, and we pass the value max speed that we get here. The only reason I might think that be confusing is because, here we have self.color gets color, which sort of just seems like a tautology, but it's not. It's actually saying that these are actually 2 different things. Color here and color here are different. Self.color is referring to the field within the object itself, and then color is referring to the value that we're providing to that field in car. So then down here, I'm essentially, this is my main here. This is what's actually running. So I define an object. I call it Tesla Model S. And by the way, if I say something that is not actually in reality of what cars are, you know what? I'm not even sorry. I don't know that much about cars. It just turns out cars are really useful for explaining this concept. So if I say something that's completely out of sync with reality, please don't send me your concerns. So we can say Tesla Model S gets car. So we're essentially saying, like when we say car and then we're passing arguments, we're actually calling the initializer. Oh, by the way, when I say, when you see underscore, underscore, init, underscore, underscore, that's actually like a built-in feature. So when you have a class in Python, certain behaviors and functions are already predefined. So when we define underscore, init, underscore, we're actually overriding the default behavior. So if we tried to pass in some stuff to a class with an empty initializer, we're essentially just going to get a bunch of nuns, and it's just going to be pretty boring. Like, it's not going to really tell us anything. There are a bunch of other built-in functions that is inherent to every object. So, for example, we're going to look at toString as well, which is underscore, underscore, str, underscore, underscore. Those are the only two we're going to look at, but I can kind of just like go through a list of them and just kind of give you an idea of how many they have. But they can all be overridden, and really most of the time you actually do want to override a couple of them, especially the string function and the initializer. So what we can do is we can say Tesla Model S gets car, so that's the name of the class, but we're really calling the initializer, and we're going to pass 4 arguments in here. So we pass silver as a string, 4, 4, and 250. And essentially what that's doing is it's creating a car with self.color is silver, so the color of Tesla Model S is silver. The number of doors in Tesla Model S is 4. The number of seats in Tesla Model S is 4. And the max speed of Tesla Model S is 250 something. I don't know. Make up a unit. I don't care. So it's 250 something, and for the purposes of explaining this concept. So the point of saying self.this is basically just saying, like, when you say self.color, you're defining an attribute of a car object called color. So what we're saying is the things that differentiate cars from each other, in our case, for the purposes of abstracting this concept of a car, is a color. So each car has a different color. Every car has a different number of doors. Every car has a different number of seats, and every car has a different max speed. When we pass these arguments in, we're essentially we're giving the functionality to the class car so that we are able to create unique car objects. So for the purpose that, like, you'll see in a second, like when I show you some more code, but like for this very basic code, I'm just showing you something very basic, or it's just something very fundamental, which is that we're creating this car. It has all these attributes, and then if we print Tesla Model S.color, we're going to see silver. When we print Tesla Model S.number of doors, we're going to see 4. When we print Tesla Model S.number of seats, we're going to see 4. And when we print Tesla Model S.max speed, we see 250. So this is the these are the results. So we see silver, 4, 4, 250. Because essentially what we're saying is print to the console whatever the color assigned to the Tesla Model S object is. And then what are the number of doors in Tesla Model S? What are the number of seats in Tesla Model S? And what is the max speed of Tesla Model S? Here, to actually illustrate that point a little bit better, let me actually pull up some code here. So let's say that that's for later. Okay, so ignore that. So this is basically just the code that that you see in the presentation itself. So we have self.color gets color, self.number of doors gets doors, self.number of seats gets seats, self.max speed gets max speed. So just to give you an idea of like maybe it's a little confusing to see like self.color gets color. I know that tends to confuse a lot of people when they first see objects. So we could actually just say like color arg, doors arg, seats arg, and then max speed arg to like to indicate that these are arguments that we're passing into the initializer function. So in this case, we could say self.color gets color underscore arg, and then self.number of doors gets doors arg. Self.number of seats gets seats arg, and then self.max speed gets max speed arg. And that does the same exact thing as before. We just change the names of the arguments. And this is here. This actually illustrates a point I'm going to be making in a second. But let's say we define this Tesla. We say it's a black car, has 4 doors, 4 seats, and a max speed of 250. And we print it out. You're going to see nonsense that looks like this. You're going to see main.car object at 0x7f, and then a bunch of hexadecimal. Is there any other way to define the attributes besides self? If there is, I don't know what it is. But I never really want to say with confidence that there is only one way to do something in Python, because Python is actually like a rather diverse language, and there's a lot of ways to do the same thing. So I don't necessarily want to say that like there is absolutely no other way to do it, but if there is, I don't see. I haven't really seen any other way. You can actually, yeah, I mean, like you can actually pass arguments into the command line. So you can do something like, let me see if I can do it. Actually, I'm not going to go into it, but like there is a way to pass in like multiple arguments. So you can say like you can pass in star args, and when you pass in star args into a function of Python, you're essentially saying like I'm going to pass, when I call this method, I'm going to pass an arbitrarily long list of arguments into this function, and we might do something with it. But this is a pretty standard way of doing it. But there could certainly be other ways of doing it. But is it a little more clear as to like what this is doing? Like why we have self.color represents the color of the car object. Color arg is the argument that we pass in here. So here black is color arg that we're passing into the initializer, and then when we create the Tesla object, self.color of Tesla is going to be black. So if anybody has any questions about that, please let me know. I'm happy to answer them. I know like objects tend to be a confusing concept for people when they first see it. But then once you get used to working with objects, like, I mean, I actually have problems not thinking about programming in an object-oriented way. I constantly struggle when I have to work with functional programming languages. Like I'm actually doing that right now with work, and it's actually it's a very different way of thinking about programming. So I'm having to kind of just like learn things as I go. Yeah, so adding the underscore arg I find generally helps, but like if I'm writing my own program, I'm generally going to write it like this, where it's just going to be like the name of the instance field, like number of seats, is going to be the same as the argument that I pass in, because it's easier for me to understand that. But like when you're first looking at objects and classes, I understand that like it's actually pretty confusing to look at that and see color here as different than self.color. And if you actually look, you'll see that, I don't know, can I zoom in on this interface? We'll see. Yep, okay, so when I put my cursor on color, you'll actually see the argument color also being highlighted, but you're not going to see self.color being highlighted. And then if I click self.color, the only thing that's highlighted is color. So That's actually the development environment knowing that these are referring to different things. Although obviously they're pretty related in terms of the functionality of our program. So if you still have questions about it, let me know. But I'm going to just move on and show you a couple other things. So as I showed you, like when we try to print out the object, so if we try to print out Tesla Model S, we're going to get something like this. It's definitely going to say main.car object at, and then this is actually a memory address. So every time you create an object, it actually gets put into memory somewhere, and all that data gets saved somewhere. And it gets deleted later once there are no threads or anything else, or like using that object with a process called garbage collection. But you don't really have to worry about that. If you work with languages like C, you actually have to worry about deleting the objects once they're put into memory. But with things like Python or Java, you don't actually have to worry about that. There's a garbage collector working behind the scenes that does everything for you. So whenever I've had to use like any C-based language, I tend to always at least once forget to destroy my objects once I'm done using them. But my point is that, like, my point of showing you this is that this isn't a particularly useful thing to see. So if I want to see Tesla Model S, I want to see a really nice like representation of what that object looks like, so that the abstraction that I'm creating seems more concrete in my mind. And I can't read this, and it even if I could just tell you like what that number was, like it wouldn't even mean anything to me. So there's actually a way to override that, though. So the default behavior of the string method, or toString, is to just print out the memory address of that object. We're going to override that method so that it does something a bit more useful. Essentially, we're going to construct a string called result, and we're just going to say, result is the color of car, string concatenation operator here, plus self.colors. So we're attaching those two strings together. And then I'm going to add this new line operator. So when you see backslash something, it's called an escape sequence. And an escape sequence has a particular use case inside of a string. So /n is one that you'll see a lot, which basically just means go to a new line. It's called the new line carriage token. It has some special name, but like it basically just takes your cursor and moves it to the next line. So in the console, you're not going to see all of this on one line. You'll actually see everything on multiple lines, so it's more human readable. Then we're just going to concatenate some more strings to result. So we'll say number of doors plus self.number of doors. Since number of doors is an integer, we can't just concatenate the integer to the string in Python 3, so we have to convert that integer to a string, so it's printable. We add another new line escape sequence, number of seats plus string self.number of seats, so we get the number of seats converted to a string, put the new line character in front of it, and then at the end we're going to say max speed plus str self.max speed, and then we just return that whole string that we just constructed. Then when we run our same code where we create the Tesla Model S with all the same arguments and we assign the same values to the fields, when we print Tesla Model S, instead of getting something kind of gross like this, where we just get that memory address, we're going to get color of car silver, number of doors 4, number of seats 4, max speed 250. So it's a whole lot nicer to see something like that. So generally, the first two things I do when I create a class are, create the initializer and then override the string method. So, I'll just do that code. One sec, I lost my, there it is. Okay. So if we define the string method here, it's somewhere in my clipboard. One sec. There we go. So when we run it, we get these useful characteristics much better representation, which is a much better representation of the object. It's much more human readable and human understandable. So I'll just put some notes here. Initializer, and then toString method. Okay. So it's pretty easy to retrieve attributes and to change attributes in Python. There is a concept called visibility, which is basically like who has access to member variables. Right now, basically everything's just going to be pretty accessible to all other classes or programs. So we're not going to really worry about visibility right now because I just kind of want to give you the basics of objects here. So let's say we have Tesla model, we have our code from before. None of this changed. But then we say Tesla Model S dot color gets green. And we print Tesla Model S again. You'll see that what we get is actually different. So the number of doors, number of seats, and the max speed didn't change, but the color of the car did change to green because we assigned a different value to Tesla Model S dot color. So now it's green. So let's go ahead and add some behavior to the class, which means adding some methods. And these are really arbitrary methods. They're going to seem really stupid. But I wanted to keep it fairly easy to understand. So I'm going to define a repaint method that paints the car a new random color, a method that determines if we can seat a specific number of people passes an argument, and a method that determines if the car qualifies as a sports car. And I'll show you what the qualifications for a sports car are according to me. So I think I might have just been blending two phrases, Josh, because I think carriage return is the character that actually brings your cursor back to the beginning. So it's kind of like the equivalent of saying like control left arrow to bring your cursor back to the beginning of the line. Which I think is \R as an escape sequence generally. And I don't know if that's what it is in Python, but I imagine that's what it is in Python. I know that's what it is in Java. Anyway, so yeah, we have the repaint method, determine if we can see a certain number of people, and determine if it qualifies as a sports car. So let's define each of these. They're going to be pretty simple methods. So the repaint method is essentially going to paint the car one of 4 random colors. The colors can be red, green, gold, or blue. And when we call the repaint method on a car object, the 1 in 4 uniform chance for each of these, the car can be red, green, gold, or blue at the end of it. So same code as before here, we have a silver Tesla Model S. And then if we call Tesla Model S dot repaint, and we print Tesla Model S again, in this case, we got color of car is red, but this is a uniform probability distribution, so we could get red, green, gold, or blue with equal probability, because randint produces a random integer 0, 1, 2, or 3, which are all the indices of these colors in the list colors up here. So silly method, but just repaint the car randomly. And then we'll have another method here, can seat number of occupants. So in this case, we actually pass in a argument. And I actually wrote this wrong. So I even, wow, that's unfortunate. That's so bad that I actually want to change it. So one sec. So this should be, yeah, we're just going to go ahead and delete that slide. can seat number of occupants method, and then I'll just show you how we'd code it in here. So let's go ahead and just define the repaint method here. We have to pass in self, indicating that this method is self-referential and not what is called a static method, meaning that is a class method. So it's not on the object level, it's on the class level. You don't have to worry about that, I mean, at the moment. So we have colors, they can be, define the list, we'll say red. Ooh, oh my gosh, I forgot how to type. Green and silver. And then self.color gets colors, random.rand int 0 to 3. So then if we, so we have to import random. Random is actually a library, so we have to import it. So if we say Tesla.repaint, and then print Tesla again, we'll see what color it is. So it initially starts off black, and then it will probably be something else. Oh, whoops. So we have to use square brackets here, indicating that. So we want to pass the result of random.randint into these square brackets here to indicate what index of colors we're trying to access. So if we run this program, now our Tesla is green, run it again. Tesla is silver, run it again. Tesla's blue, Tesla's silver again. So you get the idea. It's just going to repaint it. But now let me define the method that I'm trying to redefine here. So def can seat number of occupants. So we'll pass in self, and then we'll pass number of occupants. And essentially what we're trying to see is, are there enough seats for the number of occupants that are trying to get into this car? So we can say essentially just if number of occupants is less than or equal to self.number of seats, return true, else return false. So all it's saying is the number of occupants that are trying to get into the car has to be less than or equal to the number of seats in that car. We're assuming people don't sit on each other's laps because, that's unsafe, and we all observe good safety protocols. So if number of occupants is less than or equal to self.number of seats, return true, else return false. So that's our can seat number of occupants method. And then the last method we're going to define is Racecar method. And we're going to say that a car is a race car if its max speed is greater than 200 or its color is red, because red, as we all know, makes cars go faster. So we're going to basically check to see if the color of the car is red or its max speed is greater than 200. So as long as one of those two conditions are met, the car is indeed a race car. So let's just define that real quick. Def is car race, or we'll say def is race car. We pass in self, and we're just going to say return self.max speed is greater than 200, or self.color is equal to red. So we'll go ahead and define fast Tesla here, which is a car, we'll just keep that Tesla. So let's say we have a Honda Civic. It's a car, but let's paint it red. Say it has 2 doors, 5 seats, and a max speed of 140. So we want to see if that's actually a race car. So we're going to print Tesla.isRacecar here. And then we're going to print Honda Civic.is here. And then I'm just going to print an empty line here just so it's readable. So if we run this program, hey, they're both race cars because the max speed of a Tesla is 250 and the color of the Honda Civic is red. So even though it only goes 140 whatevers per hour, it is indeed a race car because the color is red. Now, if we change the color of the Honda Civic to blue, unfortunately, this has the effects of making the Honda Civic no longer a race car. It's really sad. So anyway, we have 3 different methods here, 3 unique methods for the car class. One Repaint that just randomly changes the color to one of those 4, red, blue, green, or silver. A method that'll determine if the car can seat a certain number of occupants, and a method that determines if the car is a race car, meaning is the max speed greater than 200, or is the color of the car red. That was so stupid. I'm sorry. It's just a really good way. Like, it just turns out that, like, cars are a really easy way to explain objects. And you'll actually find that most lessons teaching you object-oriented programming use cars or vehicles. But the actual, like, practicality or relation to reality is pretty minimal generally when you're doing the basic definitions. But I'm amusing myself. This is the full class. So basically, we have the name of the class, which is car. We have an initializer, and if you've worked with other languages, you might also know this as a constructor. So basically, it's what allows you to actually create that object, create multiple instances of that object. In this initializer, we define 4 different fields: color, number of doors, number of seats, and the max speed. We pass in these arguments, and we assign these argument values to the instance fields. We overrode the toString method so that when we try to print out the object, which, oh, by the way, like when you print out an object, by default, the Python interpreter will call the toString method of that object. So now instead of printing out the memory address, which is not human readable and not interpretable or particularly useful, we're actually going to print out a more human readable representation of that object. So something that we can actually use. Then we have a repaint method, which will change the color of the car to one of red, green, gold, or blue randomly. We have a method called can_seat_number of occupants, where basically we just check is, right, I made a mistake here. So just change this this comparison operator to less than or equal to, not greater than or equal to. We want to see if the number of occupants is less than or equal to the number of seats in the car. And then we have a method called isRacecar, which determines if the car is a race car. And then basically we're checking to see if the color of the race car is red or the max speed of the car is greater than 200. So does anybody have any questions about any of those? So yeah, I'll just give you a sec to think about it. All right, looks like everybody's good. So yeah, like I don't think that, so if nobody has any questions about that, I did assign some some homework. It probably won't take very long, and it allows you to kind of practice this a bit. And so basically in this assignment, you're going to be making a class to represent a dog. It also gave me a good excuse to just find a bunch of awesome pictures of dogs and post them all over this Microsoft Word document. So you will see pictures of dogs and the watermark of the photographer under the picture of the dog, from which I shamelessly stole this photograph because I copied them from Google image search. I literally just searched dog waving, and this is what came up. And so deal with it. So basically all you're going to be doing is you're going to be writing a Python class representing a dog. It's going to look very similar to the car class from the presentation. So we're going to say that a dog has the following attributes. A dog has a breed, which is represented by a string, an age, which is an integer, a is trained, which is a Boolean, so it's either true or false. The dog is trained or not trained in our very simple universe. The weight of the dog, which we will represent as a integer or a floating point number. That works fine too. And then the dog class has the following methods. So we have def allowed in apartment, and we're going to say that a dog is allowed in an apartment if the dog is trained and the weight of the dog is under 25 pounds. And then we're going to have another method called isPuppy, which is just going to return true if the dog is less than 4 years old. And then we're going to have a method called bark, which will print wolf if the age of the dog is greater than 3. Otherwise, we will print yap. So we're not actually returning those. We are going to print them. So make sure that you do the right one there. And then we have a method called isGoodDog, which is always going to return true. Unless you don't want it to. What if he's trained, but he never acts like this? Yeah, you're right. He doesn't. It's like dogs never act like that. Yeah, that's funny. So yeah, created. You got me. So I want you to create a dog class, have an initializer, an overridden string method, and the previously mentioned methods, so that the result of running this code here will be this. So if I put this into your program, and just exactly as it's written, the results of your program will be this. So just name your class dog. Save it as dog.py, and then just upload it, and I'll take a look at it and let you know if there's anything else. So on Saturday, I plan on assigning a project because I've realized I haven't really given you any projects. So I'm deciding on what kind of project I want to give you. I'm probably just going to have you make like a tic-tac-toe type thing or something. But hopefully, that'll be fun. But I just have to think about it. Anyway, I uploaded this to the class page, so feel free to get that done. If you have any questions, just let me know. Does anybody have any questions about objects, classes? So obviously the actual subject of this is pretty deep and dense. There's always more things to learn about object-oriented programming. It's a fairly deep subject. But I just wanted to show you enough so that you could define your own class and objects so that you'd feel comfortable doing that in a program. And basically, this is the last thing I wanted to show you before I felt comfortable assigning just a more interesting project, like coding a functional game. So. I always did tic-tac-toe, so I might not assign tic-tac-toe, but don't be surprised if that's what I have you make. on Sunday. So, does anybody have any questions? Hello, Saeed. Thank you for coming to the stream. Unfortunately, I think we're actually finishing up now. But I do stream Sunday and Wednesday, so feel free to join me for those. I will be sure to include more dog pics for you next time, Josh. It certainly doesn't bother me to find good dog pics. And in a world with an uncertain future, I think dog pics are kind of the panacea for all that ails the world. Except untrained dogs that never act like this. But really, that's not the dog's fault. I'm actually mad at the owner of that dog, not the dog itself. Dog can't help it. I'm barely a trained human. So anyway, any question? I'm always delirious at this point in the day. Any questions about classes, objects, object-oriented stuff? Even if you want me to go into like something I didn't cover or just like something I briefly glossed over, feel free to ask. I have no problem going over something. If not, I will play Final Fantasy VII. All right, guys, thanks for joining. Try out the assignment, and then hopefully I will see everybody on Sunday. Have a good night.